Welcome to the Deep Dive.
Yeah.
You know we love to go deep on all sorts of topics, and today we're going to dive into the fascinating world of batteries.
Batteries.
It's a technology that has really become essential to our modern lives.
It really has.
And honestly, they're so essential that we almost don't even notice them anymore. They're just kind of there.
Yeah, they're invisible.
But we are going to pull back the curtain on the world of batteries today. And our source material for this deep dive is a report written by Jörg-Owe.
Okay.
And this report covers all sorts of different aspects of battery technology, from its history and development to its impact on the future.
It's amazing to me how much we really do take batteries for granted. I mean, They power everything, our devices, our vehicles, and increasingly our cities.
It's true.
But there's so much more to them, and Schneppat's report really highlights all of that.
It really does. I was so fascinated to read about the history of battery technology.
Oh, yeah.
Because honestly, it's full of surprises. For example, did you know that the very first device to store an electric charge wasn't even a battery?
Yeah, that's right. It was the Leyden jar.
The Leyden jar.
Invented way back in 1745.
Wow.
It was basically a glass jar with metal foil lining the inside and the outside. And it could store a static charge, but it wasn't very portable.
No, I imagine not.
Or practical for everyday use.
Can you imagine trying to power your smartphone with a Leyden jar?
Yeah, right?
But then in 1800, Alessandro Volta came along and invented the voltaic pile.
Yes.
Now, that was the first true battery, and it really sparked a revolution.
It did.
In scientific experimentation and technological development.
And what's really fascinating to me is that the basic principle behind the voltaic pile is still the foundation of modern batteries.
Really?
Yeah, you use different metals and an electrolyte to create an electrochemical reaction, and that was really the groundwork for everything that followed.
So Volta's invention really changed everything.
It did. It really set the stage.
And then the innovations just kept coming.
They did.
Throughout the 19th century, we saw the development of more efficient and longer-lasting batteries, like the Daniels cell in 1836.
Right.
And the dry cell in 1886.
Yeah.
And it's interesting because these innovations coincided with the Industrial Revolution.
Oh, absolutely.
And it makes you wonder if it's not a coincidence that the ability to store and use electricity was a driving force behind so many of the era's transformative inventions.
I think that's definitely true. And I think what's really remarkable is that a lot of the challenges that these early battery pioneers faced, like improving the energy density, the cycle life, and the safety, are all still relevant today. And that's something that Schneppat points out in his report.
Absolutely. And it really shows how the development of battery technology has been this ongoing quest for better performance and more efficiency.
Yeah, it's a continuous process.
Yeah. So let's fast forward to the present.
Okay.
And as Schneppat explains in his report, there are basically two main types of batteries. There's primary batteries, which are single use, and secondary batteries, which are rechargeable.
That's right. Think of it this way. Your typical alkaline batteries that you use in a remote control. Those are primary batteries.
Yeah.
Designed to be used once, and then you throw them away.
Right.
But the battery in your smartphone or laptop, that's a secondary battery. That's a lithium-ion battery, and you can recharge it hundreds of times.
Hundreds of times.
Before it needs to be replaced.
That's incredible.
Yeah, and when we talk about battery chemistries, there's a whole periodic table to explore.
Oh, I bet.
But these days, lithium-ion batteries are definitely the stars of the show.
Yeah, you see them everywhere.
Especially in things like electric vehicles and portable electronics.
It makes sense. Lithium-ion batteries have such a high energy density.
Yeah, they do.
They can store a lot of energy in a really small package.
But as Schneppat mentions in his report, there are trade-offs with any battery chemistry.
Yeah, nothing's perfect.
Right, and lithium-ion batteries are no exception.
Yeah, I'd love to hear more about those trade-offs, but before we get into those complexities of lithium-ion batteries and other emerging technologies, maybe we should take a step back and really just demystify some of the basic science behind how batteries work.
Yeah, let's break it down.
Because some of these terms can be a little intimidating.
It can.
So how does a battery work?
Okay, so all batteries have these three main components: an anode, a cathode, and an electrolyte.
Okay, I'm already getting lost.
All right, well, think about it this way. Imagine a battery as like a little chemical factory.
Okay.
Where electrons are the workers.
Okay, I like that.
So the anode is like the electron departure lounge.
Okay.
It's the negative terminal of the battery where the electrons are released during the chemical reaction.
So they're leaving the anode.
Exactly. And the cathode is like the arrival gate.
Okay.
The positive terminal where the electrons want to go, and the electrolyte is the pathway between the two.
Okay.
It lets those electrons flow from the anode to the cathode.
So the electrolyte is like the highway.
Yeah, exactly. And that flow of electrons, that's what creates the electric current that powers our devices.
Wow.
And the specific materials that are used for the anode, the cathode, and the electrolyte, those determine the battery's voltage, its capacity, its energy density, and even its safety.
Wow. So there's a lot of chemistry and engineering that goes into optimizing battery performance.
Oh, yeah. It's really incredible.
That's where things start to get really interesting. And that is what we are going to get into next time when we continue this deep dive into the fascinating world of batteries.
Looking forward to it. Welcome back. So before the break, we were talking about the different parts of a battery, the anode, the cathode, and the electrolyte.
Right.
And I think it's so fascinating how the specific chemistry of those components can really change how a battery performs.
Yeah, it's like every battery has its own personality, its own strengths and weaknesses.
I like that. So let's dive a little deeper into some of those personalities.
Okay, let's do it.
So one of the key things that makes batteries different is the type of electrolyte that's used. And Schneppot explains that they can basically be classified as either aqueous or non-aqueous.
Okay, now hold on. I need a little refresher here.
Right.
What's the difference between aqueous and non-aqueous electrolytes?
Okay, so think of it this way. Aqueous electrolytes are water-based.
Okay.
So they're typically used in batteries like lead-acid batteries.
Okay.
And nickel-cadmium batteries, which you might know from car batteries or older rechargeable devices.
Oh, so those are the kind of batteries that can sometimes leak if you're not careful.
That's right. Those are the ones.
Okay.
Aqueous electrolytes are good at conducting electricity, but they have limitations when it comes to things like energy density and temperature stability.
Okay, so they don't do well in extreme heat or cold.
Right.
Got it. So what about non-aqueous electrolytes?
Okay, so non-aqueous electrolytes are typically made up of organic solvents, and they allow for higher voltages and greater energy density, which is why they're so popular in portable devices, but they do come with some safety considerations.
I was just thinking about that because I've heard stories about lithium-ion batteries overheating or even catching fire.
Yeah, and that's a valid concern, and it's one of the challenges that researchers are working on constantly because non-aqueous electrolytes can be flammable. So battery design and thermal management are really crucial for safety.
So it's kind of a trade-off to get that higher energy density, but you have to be more careful about how you use the battery.
Exactly. And that's where the chemistry of the anode and cathode also come in, because the materials you choose for those components will have a big impact on the battery's performance. Things like voltage capacity and cycle life.
And cycle life is basically how many times you can charge and discharge a battery before it starts to wear out.
Exactly. And different battery chemistries have different cycle lives. Lead-acid batteries, for example, typically have a shorter cycle life compared to lithium-ion batteries.
Okay.
So that's one reason why they're not ideal for applications that need to be charged and discharged frequently, like in a smartphone.
Yeah, that makes sense. So lead-acid batteries are good for like a burst of power.
Right.
Like starting a car, but not for being charged and discharged over and over again.
That's right. They're workhorses for specific applications,
Right.
But they're not as versatile as some of the newer battery chemistries.
Speaking of versatility, lithium-ion batteries seem to be winning these days, especially with all the electric vehicles out there.
Yeah.
But Schneppot's report also talks about other types, like nickel-cadmium batteries.
Yeah, nickel-cadmium batteries used to be really popular, especially in things like power tools, because they can handle those extreme temperatures.
Okay.
But they have this weird thing called the memory effect.
The memory effect.
Which can actually reduce their capacity over time if they're not fully discharged before being recharged.
Wait, so it's like the battery remembers how much it was discharged and then it limits itself?
Yeah, that's a good way to think about it. And it's one reason why nickel-cadmium batteries have kind of fallen out of favor as other technologies like lithium-ion have gotten better.
So lithium-ion's the champ for now, but I'm sure there are always new contenders coming up.
Oh, yeah, it's like a constant race for better performance, more efficiency, and sustainability.
And that brings us to, I think, the elephant in the room, the environmental impact of battery production, especially lithium mining.
Yeah, that's something we can't ignore.
Right. Schneppot spends a lot of time on this in his report.
Yeah.
And it's a good reminder that even technologies that are supposed to help the environment can have unintended consequences.
It's complicated, and there aren't easy answers. The demand for lithium is just exploding as we're all switching to electric vehicles and renewable energy.
Right.
But the way we get lithium can have a big impact on the environment and on people.
Yeah. The report talks about the lithium triangle in South America, where most of the world's lithium comes from.
Right.
And the process uses a lot of water, which can deplete local water resources and really disrupt ecosystems.
And there's also the risk of pollution from lithium mining, toxic chemicals leaking into the environment.
It's a reminder that we need to think about the whole life cycle of a product, from where we get the materials to how we make it, use it, and dispose of it.
Absolutely. It's all about creating a circular economy where we minimize waste and reuse valuable materials.
So like recycling, but on a much bigger scale.
Yeah, exactly. And there's some really cool stuff happening in that area, like direct lithium extraction, or DLE, which uses less water and is more efficient.
And there's urban mining, where we recover lithium and other materials from electronic waste.
It's like turning trash into treasure.
It really is. So sustainability is definitely a top priority for the battery industry.
It is.
But Schneepat makes it clear that it's not just about the environment, it's also about the people involved.
That's so important. We need to make sure that the people who are mining lithium are treated fairly.
Right. The report talks about concerns about working conditions in some lithium mines, especially in places where there aren't strong labor laws.
And we have to think about the impact on indigenous communities whose land is often affected by mining.
It's a reminder that technology should never come at the cost of human rights.
Absolutely. It's about finding a balance between meeting our needs for batteries and protecting the environment and the people involved.
It's a tough challenge, but it's something we have to keep working on.
Yeah.
So now I think we should shift gears and talk about the future, all this amazing new technology that's being developed.
I'm ready.
Like solid-state batteries and quantum dot batteries.
The future of batteries is so exciting.
It really is. I can't wait to hear about it. Okay. What does Schneepat say? So before the break, we were talking about the future of batteries, all these new technologies that are being developed.
Right. Solid-state batteries, quantum dot batteries. It's a really exciting time.
It is. I'm excited to hear more about it, but before we dive into those, maybe we should talk about, what makes a battery good.
Oh, yeah, that's a great point.
What are the things that scientists and engineers are trying to improve?
Right, so one of the most important things is energy density.
Energy density.
And Jörg-Owe really emphasizes this in his report. Basically, it's how much energy a battery can store compared to its size or weight.
Okay, so a battery with high energy density can pack a lot of power into a small package.
Exactly. That's why lithium-ion batteries are so great for smartphones and laptops.
Right, and for electric cars.
Especially for electric cars, because the higher the energy density, the further a car can go on a single charge.
So it's all about range.
Range is key. Nobody wants to worry about running out of juice in the middle of nowhere.
No, definitely not. But it's not just about how much energy a battery can hold, right? It's also about how long it can hold that energy.
You're talking about cycle life.
Cycle life.
Which is another super important factor.
Okay.
Cycle life is how many times you can charge and discharge a battery before it starts to die.
So some batteries can handle more cycles than others.
Exactly. Lead-acid batteries, for instance, they have a shorter cycle life than lithium-ion batteries.
Which is why you don't see them in smartphones.
That's right.
They're more for, occasional use.
Yeah, like starting a car.
So another important factor is charging rate.
Oh, yeah. Especially with electric vehicles.
Right. Nobody wants to wait hours for their car to charge.
Exactly. We want to be able to charge quickly and get going.
But I've heard that charging too fast can damage a battery.
That's true. If you force too much energy into a battery too quickly, it can overheat.
Okay.
And that can shorten its lifespan. So that's why it's important to have smart charging systems.
To protect the battery.
Exactly.
So another thing we need to think about is thermal management.
Yes, thermal management is crucial.
Okay, so basically keeping the battery from getting too hot or too cold.
That's right. Batteries generate heat when they're being charged and discharged. And if that heat isn't managed properly, it can cause problems like reduced performance or even safety hazards.
Right, like those lithium-ion batteries catching fire.
Exactly. That's a serious concern, and the industry is working hard to address it.
So there are a lot of different approaches to thermal management.
There are using cooling systems, designing battery packs in a smart way, and even developing new battery chemistries that are less likely to overheat.
So it's a complex problem.
It's a delicate balance of chemistry, physics, and engineering.
So let's talk about the future now.
Okay.
We've talked about solid-state batteries.
Yes.
And quantum dot batteries.
Yes.
What can you tell us about these technologies?
Well, solid-state batteries are really exciting. They have the potential to be even better than lithium-ion batteries.
Really?
Yeah, they could offer higher energy density, faster charging, and improve safety.
Why are they safer?
Because they use a solid electrolyte instead of the liquid one.
Okay.
So there's no risk of leaks or flammability.
So it's a solid material that conducts ions.
Yes, it's pretty amazing.
It is. And what about quantum dot batteries?
Quantum dot batteries are fascinating. They use these tiny semiconductor particles called quantum dots to achieve really fast charging and super high energy density.
So they operate at the atomic level.
Essentially, yeah.
That's incredible. So we could charge our phones in seconds.
That's the idea.
Are there any other crazy battery technologies out there?
There are metal air batteries, are another one to watch.
Metal air batteries.
They use a metal anode and an air cathode, so they're literally breathing air to create electricity.
Wow, breathing air, that's amazing.
They have incredibly high theoretical energy density.
So electric cars could go thousands of miles on a single charge.
Potentially, yes. But there are still challenges to overcome before they become mainstream.
Well, it sounds like the future of batteries is full of possibilities.
It is, and it's important to remember, as Jörg-Owe says, that we need to develop these technologies responsibly.
Right.
We need to make sure that we're not harming the environment or people in the process.
That's a great point. So as we wrap up this deep dive, I think the takeaway is that technology is a tool.
Yes.
And it's up to us to use it wisely.
Absolutely.
To create a better future for everyone.
Well said, and we hope you've enjoyed this deep dive into the world of batteries.
I know I have. It's been fascinating.
It's amazing how much innovation has gone into this technology.
It really is, and the future looks even more exciting.
It does. So we encourage you to keep learning about batteries.
Yes, keep asking questions and be part of the conversation about how we can create a more sustainable future.
Thanks for joining us.
And we'll see you next time for another deep dive.